Thanks, Juliana. Hi, I'm Robert. I'm talking to you out of my home in Berlin, in Germany. And I'm having with me Simon sitting 16,000 kilometers away from me. He will take over about halfway of our nice little walkthrough. This is what we're going to talk about. We will first say some words about the subject matter, the OptiMods, why, how, and what. Then I'll spend some time walking you through a so-called mod for optimal portfolios. And Simon will take over to talk about workforce scheduling. And then we'll circle around various topics on open source, GitHub com, pull requests, forking, and so forth. So that's the menu. And I'm not exactly sure about all your backgrounds out there, but I'm pretty sure that some fraction of people will have a serious background in optimization and have approached mathematical optimization or are currently using mathematical optimization, and in particular MIP technology, so mixed integer programming, mixed integer optimization. And for those of you, I would like to have one request for you. Maybe sit back for 10 seconds and think how you approached mathematical optimization the first time and what this looked like, this experience. And so I did this exercise this morning, and here is what happened to me. So I was remembering that I was stunned by a wall of words, not a cloud, that would be nice. No, it was really a wall of words. And the reason is that mathematical optimization is an extremely mature technology. So 70 years of research and practice have made this a cornerstone of solving practical problems. And I think it's just natural that you have a ton of important concepts, a ton of important lingo, and so many interesting aspects that play into this, that it can actually be also a barrier between you as someone who just wants to have a problem solved and a useful technology, MIP, mixed integer optimization. And with the OptiMods, we at Gurobi, we try to give you a hand just to help you overcome that wall without having to learn all these concepts, getting familiar with all this out there. And this is what we call the OptiMods. And to give you an explanation from different angles, an OptiMod is a tool to solve a specific practical problem. An OptiMod has a data-driven API, and it integrates with the greater Python ecosystem. An OptiMod takes data in natural form and returns a solution in natural form. Well, I've put quotes here. Why that? Well, because every specific problem out there may have its own convention, what is natural in terms of input-output. So this must be tailored for the purpose. And what happens in the back, of course, that's where Gurobi comes to play. An OptiMod solved a mathematical optimization problem using Gurobi's mixed integer technology without the need to dive into mathematical modeling. And of course, the compromise you have to make, I mean, why is mathematical optimization and modeling so big? Well, because it's extremely flexible. You can, everything you can phrase in integrality constraints, linear relations, maybe quadratic relations, maybe more nonlinear relations on a mathematical basis, you can eventually solve by Gurobi. That's the flexibility. You give up by that, right? That's the first point here. It's a tool to solve a specific practical problem. And what makes a problem practical? Well, we're not exactly sure. That's to be determined by everyone using optimization. But we at Gurobi, we sat together and thought about what could be a good set of problems we want to be represented as an OptiMod first. And that's our first seed we come up with. So let me just drop one sentence for each of the mods we have. Maximum bipartite matching. This is a problem where you want to match things in A to other things in B, and each thing can only be matched once, more or less. Then you have least absolute deviation regression. I mean, regression is in everyone's mouth today. Everyone knows through machine learning how important regression problems are. And there's one interesting variation of regression where you don't measure like the mean root square error, but where you measure the absolute deviation from your data. And this has some advantage in interpretability. So that's why we include it here. It is very naturally solved by linear optimization. So that makes a good example where you don't need to know about LP and optimization, but you can just put in your data for the regression and get back the optimal regressor. Minimum cost flow is concerned with sending things through a network which has capacities and cost on the links. A lot of problems can be abstracted that way. And in fact, a whole mathematical theory behind minimum cost flow is a standard tool in mathematical optimization. Here, we just want to give you something at hand to solve your network flow problem without digging into all of that. Then we have a more graph theoretic thing, the maximum weighted independent set problem, where you use asked to select a maximum number of things out of a connected set, but these must be all non-adjacent. We have the mean variance portfolio mod, which I'll be talking in detail in just a minute. We have quadratic unconstrained binary optimization, in short QBO. This has got some attention, I would say, through the most recent hype in quantum computing, because this kind of problem is somehow tailor fit for quantum computers. The good thing is you don't need to wait for a quantum computer to arrive at your basement. You can solve it today using MIP technology. And we have workforce scheduling, which will be detailed by Simon in just a bit. So where to get it? Well, there's just one way. You do pip install Gurobi-OptiMods, and this will fetch it from you for you from PyPI. The documentation is hosted on Read the Docs. Let me maybe just show you how it looks like. All right, so this is the landing page of documentation. What you will find is you will find installation instructions. Maybe Matthias or Mario, maybe you can just post the landing page of the OptiMods into somewhere where people can see it, can browse along while I'm talking. Installation, usage, it's pretty straightforward. If you're used to using any Python package, it's more or less, it follows the same semantics. Most importantly, this is the gallery of OptiMods. I've been showing to you on the slide. Each OptiMod comes with some detailed documentation along with examples. And why don't I think I will just start walking through documentation for the portfolio OptiMod, maybe right here. All right, so mean variance portfolio. This is a very classical problem actually in operations research and also in mathematical finance. So the general game is you have some wealth to allocate into a number of different assets, and you ask yourself, oh, well, where should I put, how much should I invest in which asset? And as a mental model, you can just think you have like, I don't know, $100 and you want to invest this into 8 different stocks, and you wonder what is the optimal allocation of my $100 to each of these stocks. It's not bound to stocks. Everything that can abstractly be an asset can be phrased as such a problem, be it bonds or securities. It really doesn't matter. And so let's see how this works. So we have our $100. We want to invest them into various risky assets. And what the underlying principle in mean variance portfolio is that the returns of each assets are random variables. And hence, to get any insight on allocation, you need to provide estimators for the first and second moment, or put differently, you have to have a way to estimate the return of each asset and the covariance among the assets. The first is to maximize your profit more or less. The second is to have a handle on the risk. And mathematically, what it means, if you're interested, you don't need to, but what it means mathematically, you have your vector mu, which is your return estimator, and you have your covariance matrix sigma, which is your risk estimator. And what you're asking to is, for a balancing parameter gamma, you want to maximize return minus the risk of that investment. And depending on how you choose your gamma, you will get different portfolios representing different trade-offs of return and risk. And so here's one very simple thing, how to explore this a little bit in portfolio optimization. In the OptiMods, we have included an example data set, which is used throughout to demonstrate all the functionality and all the concepts that are involved. So here in this case, our example data is just historic returns of, I think it's 8 or 10 totally fictional assets, AA, BB, CC. I mean, these are not typical stamps. And what you see there is the logarithmic historic return over a time series of 245 data points. And this is very typical data. And one very naive way, but at the same time, not so bad in the end, is to take this time series of historic returns and just use standard pandas functionality to compute covariance and estimators from that. So you roughly say, oh yeah, all the assets will behave in the future roughly as they did in the past. And then you average it, and that's the return. And the covariance directly from the Gramian matrix gives you the risk estimator. Okay, let's do this. So let's copy that in here. Bam, there you go. So what does it do? So very simple. First thing is just an import to get the example data into the namespace. The second is we get our portfolio class to do the computation. This will load the data into a data frame, compute the covariance matrix on it, compute the estimator, and because 100 is such a nice number, we just choose the risk aversion coefficient to be 100. And then what you do is you instantiate a class of the mean variance portfolio given the mu and given the covariance matrix. And you ask the object to compute you an efficient portfolio for the provided parameter of gamma, which is 100. And the output, you see it here, will be a data class having a number of fields. So most importantly, you get back the fraction of investment you should do for each stock. So here the solution says we should invest about 42% of our $100, so about $42 into the stock AA, $24 into stock DD, and so forth and so forth. And there are also quite a bit of tiny ones that you probably wouldn't execute an investment on, but there they are. And the returned data class also tells you what the estimated return is of your portfolio and the estimated risk given your estimator. So that's the general procedure. And if you look a bit more closely, so all the OptiMods are built like this. So you will always find a data set to play around with, that you know how to organize your own data to put it into the mod. And then it will walk you through how to use it. And all the examples should be copy pastable, runnable, so that you have no friction whatsoever in figuring out what to do. And so what happens in the portfolio mod that you can also impose a number of options. So for example, we could say that whenever we buy into any position, we want to do so at, let me pick another example. That's better here. So when we make our allocation, we could ask ourselves, hey, I don't want to pay transaction fees for all these 10 positions. Can we maybe find an optimal portfolio that trades only 3 positions? So let's try that. So you can do this. This is largely the same as before, but we can specify this additional feature of our portfolio as a keyword parameter to the one computational function this mod has. It's that simple. And if we look at the results we've got from that portfolio, we see that all these tiny transactions have been neatly cleaned out. And what survives is only 3 positions as requested. Yep. And then you can actually do quite funny things with that. For those of you who know a little bit about mean variance portfolios, there is this concept of efficient frontier, which are all the non-dominated points in the portfolio space given the risk aversion. And feel free to browse the documentation a little bit. So you can ask yourself, how does the efficient frontier look like if I put cardinality constraints on my investments? And that's something you cannot do without MIP technology, because you need to take the discrete decision of, should I invest into that asset or shouldn't I? And well, that's exactly the kind of problem that Gurobi can solve in the back, but you don't need to bother to think about modeling this yourself. So, and you can, with very little code, make very interesting insight. So here in blue, you see the efficient frontier for the unconstrained investment. And then the orange, green, and red. Oh, sorry, that's red and green. I thought I had changed it. I'll fix that later. You see that already with using only 3 assets, so that is automatically avoiding a lot of tiny transactions, you can get efficient portfolios that are very close to non-dominated points. So that tells me that, well, it's probably an artificial data set, but yeah, why don't you try that yourself on a real world data set and see how many assets you really need to replicate some portfolio that is almost efficient. Yeah, so I hope you liked the portfolio mod, and at this point in time, I think I would like to hand over to Simon. Are you ready to give us a walkthrough to the workforce scheduling?
For sure. Yeah, let's switch gears from finance to staffing. Oh, I think I need you to stop sharing so I can jump in, Robert. I can't forcibly take it from you, it seems. Much as I would like to. All right. So yeah, as Robert said, I was going to take a look through the workforce scheduling OptiMod. So I'll track it down in the gallery here to find the documentation. So as we're doing for most of the OptiMods, I think the right kind of headspace to be in when thinking about these is put yourself in the mindset of someone who's relatively new to optimization, knows their way around manipulating data, knows their way around Python, the whole PyData stack, but isn't so familiar with optimization in depth. So the example I want to go through here to illustrate the workforce scheduling mod and how we see it being used is, let's say I'm a data scientist. I've got some historical data available for customer demand in a small business, maybe in a warehouse application or just a kind of retail store. And I know how to extract that data, manipulate that data, and I can use this pretty easily to build some predictions of staffing requirements. So that's all well within my wheelhouse. But when we get to the optimization step, that's something that I'm not so confident doing myself. And this is where we think the OptiMods can really help. So the underlying question here is, how do we take someone who is pretty familiar with predictive analytics, but and introduce them to prescriptive analytics without all of the word cloud headaches that Robert mentioned earlier. So to go through a little bit of background on this, let's say I've got some of my historical customer data for my business available. That can be living in, say, a SQL database somewhere. If I'm working in the Python, the PyData stack, this is all pretty accessible, so I can grab that data out using Pandas, do a few little tweaks, and produce for myself a plot of customer demand across different days of the week. And I can see, looking at this data, that my busiest day is obviously Saturday. I expect in a staffing problem to need a few more staff on that day. Sunday's quiet, the weekdays are maybe fairly consistent. So from this historical data, I could build maybe the simplest predictive model imaginable. So let's say I know that I know exactly how many staff I need per customer in my business. So I know that for a given batch of 20 customers coming through my business in a day, I just need one staff member to handle that workload. So I can take my daily averages and build a really simple model based on the day of the week, the number of staff required. So I've got a dead simple predictive model here. And then say my task is to plan shifts, plan employees on a roster for the next month. I can just go ahead and extrapolate from this data. So I can build the beginnings of a roster plan for the month of June by taking the set of dates I need, extracting the day of the week, and then mapping that onto my predictive model for staff requirements over the days of the week. So what I have here is the number of staff required in my business per day of the week. Through another data source, I should have some staff availability. So that might be living in, say, an Excel sheet. That's also easy to integrate from the using Pandas. I can pull that information in and just get a table of availabilities over the next month that my staff have given me. So I've got the makings of a roster here. I know essentially what my requirements are. The question is, what do I do next if I'm not an optimization expert? So I could go back to this Excel sheet of availabilities and start just making some random assignments and hope it all comes together. If you've tried this, you'll know it only works for so long. I could do some research. I could start Googling things like how to create a shift roster. And so I've tried this. I've tried Googling how to create a shift roster and shift scheduling in Python, and you end up really at two ends of the spectrum. So you either get something highly non-technical, showing you how to sort of deal with the absolute basics of data in Excel, but doesn't actually help you solve a constraint handling problem to come up with a roster. Or you get right into the depth of the detail of mathematical programming articles. You might see some examples on the Gurobi website of the details of how to implement this, or long discussions of variables and constraints. So with the OptiMods, our aim is to really allow people to leapfrog that step. So assuming we're able to find the OptiMods documentation, first of all, then these documentation pages, as Robert pointed out, should give a pretty clear description of the input data that's needed for a given mod and the business problem that this mod is solving. So with the package installed, there's simple examples given for all of the mods. So I could do a quick run with the provided example data and get out a schedule. And then my task is to take the the data that I've already got and try and munge this into the appropriate format to apply this mod to my problem. So our approach to describing that is to essentially provide along with API documentation, provide these simple examples where it's very clear what the input data specification is. So if you have a look at the workforce scheduling mod, you'll see that we need essentially 3 pandas data frames. One is the data frame specifying staff availability. So we have at least 2 columns in this data frame. The name of a worker that we could assign to a shift and the date of the shift that they're available for. And there'll be a row in this data frame only if the given worker is available for that shift. There's optionally some preference data. So if you want workers to be able to provide weightings on different shifts that they'd prefer. In my particular case, I don't have that, so I can leave it out in this case. We need shift requirements. So essentially in this OptiMod, we're considering that all staff are created equal. So we need a certain number of staff on a given time, for a given shift. But we don't have any particular skill requirements. We assume everyone can cover the required work. So we just need a data frame here specifying the shift dates that we need and the number of required workers on that day. And finally, we need to pass it a worker limits data frame. So this describes for a given worker who might be on my roster, the minimum and maximum number of shifts that they should be assigned in the coming month, or in the duration of any roster that we're looking at. So our aim with the OptiMods is to create this data in, data out API. So the skill needed to get one of these working is just, all you really need is the ability to manipulate your data into the right format. If you're comfortable with this whole Python suite of data science packages, then hopefully this is a pretty straightforward job. So my availability data frame, I've got to do a few little pivot operations to turn my Excel sheet form style data set into this shift worker availability data frame. So this matches up nicely with what the documentation's asking me for. My shift requirements were pretty much already in the right state. I just need to rename a couple of columns to get these to line up. Worker limits, I didn't really have this from the initial data set, but let's assume I have some requirements around this. So over the next month, I don't want to allocate all of the shifts to one person for every day they're available. I want some form of balance. So I can say that everyone over the next month will have between 5 and 10 shifts, and can pretty straightforwardly construct the data set that I need there. And this is basically all I need for the inputs. So actually solving the model is almost a copy paste. So I'll get rid of the data sets component of the example, and I'll get rid of the preferences part of the model, because in this case, I'm just assuming everything is equal. And I'll pass in my data instead of the example data. What I'll see solving that is a little bit of Gurobi logging. So this comes from the solver. We don't hide this away by default. There is an argument in all of the mods if you do want the solver to just silently do its work. And what I'll get back from that is my assigned shifts data frame, which constructs all of my worker assignments. So this data frame, and this is also all described in the documentation, this return data frame is just a subset of the availability data frame. So it's all of the assignments, which obviously must be chosen from that availability set. And we're even given a nice simple example of how we might want to display this data very simply, just to show the final roster. So another pivoting operation. Again, this is not relating to the underlying optimization. It's just done by handling the output data that's already in a Pandas native data frame format. And then I can have a look through my schedule that way. It's hopefully clear looking through this that if you were to look back at the shift requirements, just counting along, it's clear that all the requirements have been met, and we've got a roster. So yeah, this is one use case that we see for these OptiMods. To essentially, you'll notice that in using it, you're not having to touch any of the underlying optimization. You pass in data frames, you get out data frames. And there are more requirements I could incorporate. So if you read on through the documentation, you'll see there are ways to enforce breaks. So we can essentially tweak the this worker limits requirement, make it a rolling rostering requirement, so that you're enforcing not too many shifts in a row for any given worker. And this is the extent of what we've implemented so far. But anyone, if you're familiar with the workforce scheduling area, you'll know that there is an absolutely huge range of requirements that could be incorporated, and there's a few that we're looking at incorporating next. The tricky thing becomes where the scope of this mod should really end. Right, so let me just do a quick swap of screens. Hopefully those two examples give a bit of an idea of where we're going with the OptiMods and how we expect them to be used, and hopefully how they could be useful to you. So I mentioned the scope of the current OptiMods, particularly where the workforce mod kind of ends, and so how far we've implemented so far. So that's a natural place to talk about kind of what's next for the project. So first things first, I wanted to mention the group of people that's been involved so far. So we've had about a dozen of our technical experts across the company involved in building the OptiMods, and that's been quite a nice approach. It means we've come up with we've been able to collect quite a wide range of problem domains within the OptiMods. We haven't narrowed into the sort of one field that would come if we just had one or two people implementing. What we'd like to see next is to add some people from outside Gurobi into this group and get some external contributors in the project to add a bit more, add some further variety, and really start to tailor these to more and more use cases. So as for how we're going to do that, so Robert has already mentioned that this lives on the project lives on GitHub. It's installable from PyPI. The documentation lives on Read the Docs. The repository is public and it's under an Apache 2 license. So this is freely usable in academic and commercial contexts, and it's open for contributions. So we've put together a pretty detailed contribution guideline in the documentation, which should help you get up to speed with developing and modifying mods. We've hopefully made it as easy to get started as we could. And we're operating using a normal GitHub workflow. So we use issues and pull requests to discuss and review contributions from outside Gurobi and inside Gurobi. If you're interested to join the project, and that can be anywhere from reporting bugs, fixing bugs, enhancing existing mods, or proposing and implementing entirely new mods, then the place to visit first is the issues page on the Gurobi OptiMods repository. You'll see we've already got quite a number of open mod proposals that we've generated internally. These are topics that we have thought about that we thought might be interesting next ones to tackle. There's a few for mod enhancements as well. So possible directions we could take the existing mods and functionality we could add. So if any of the existing issues interest you, please go ahead and comment there on what functionality you think should be added and how it should look. If you have a new mod that you'd like to propose, then please feel free to open an issue here and describe what you're looking for, and also tell us if you're interested in implementing it yourself. So this is absolutely a pull requests welcome scenario. We'd like to see you open an issue first so we can discuss kind of how a new mod should be implemented, but we'd be really happy to see some pull requests coming in implementing new mods. I think there's a couple of questions on this in the Q&A, so maybe we'll get into that in a bit more depth there as well. But part and parcel with contributing new mods is you'll see that all of the mods have a kind of like a well-defined scope. And there are limitations to what you can do with a given mod. There's a trade-off in a project like the OptiMods where you lose the flexibility of having access to the underlying Gurobi API. So you can't build models as flexibly as you can if you just use gurobipy directly, for example. And the mods don't cover every use case. We need to define a scope, otherwise the APIs for these mods just get a little bit out of control. So if the question is, this mod almost suits my requirements, but I have some small tweaks I need to make, then your first step is probably to fork the repository and start hacking away and adding in new features. We've done our best to make the code as accessible, readable, modifiable as possible. So feel free to take that code and use it as a starting point. If you come up with something that's useful and you think will be useful generally to other users, we'd love to see you contribute it back to the project. But you can also use the OptiMod code as a starting point for other projects that get really specific into your use cases. And that is about all we wanted to go through today. Did you have anything to add, Robert, on the contributing, hacking, anything front before we wind up?
Just reiterating, contributions welcome. If you like it, and if you buy into the idea that we should empower people using optimization, even though without going through the pain of mathematical modeling. If you buy into this, please contribute. I think this will help a lot of people.
All right.